Do the locomotion with BBC Learning Zone in 50 minutes when Open Science discovers how all kinds of animals tackle the challenges of moving about on land. That's after Janus Aqua reveals that the biggest threat to humanity could be very small indeed.
Human cloning has become a step closer.
Comets smashed into the Earth, devastating animal and plant life.
Muscly mouse seems otherwise normal.
For a temporary ban on the genetically modified crops.
They say the discovery could have important medical implications.
Viruses seem to be in the news more and more, and Hollywood takes it one step further with films like The Andromeda Strain and Outbreak, which show humanity on the brink of extermination by a rogue virus. Well, is this worst-case scenario just hype, or could it really happen? I'm reading this book, and it may look like science fiction, but it claims to be science fact, and it doesn't make reassuring reading.
We now know that the most dangerous new pandemic is likely to be viral in origin. I've called it Virus X, with X the logical derivative of extinction. They're all too capable of taking us by surprise. To cause our extinction, Virus X would need to take two steps. First, it would have to kill everybody, or almost everybody.
Frank, I've just been reading your rather alarming book, and I'm wondering just how dangerous viruses really are.
Well, viruses are very, very dangerous for a number of reasons. We have antibiotics that help us deal with bacteria, but antiviral drugs are very early in the developmental stages, so we can't really cure most viral illnesses. Now, this century in particular, and in the last 40 years even more so, new viruses have been emerging to threaten humanity on a scale that's never been seen before. Everybody, of course, has heard of the AIDS virus, HIV-1, which kills 299 out of every 300 people it infects. And we think now it's going to kill at least 40 million people globally, maybe a lot more, I hope not, but maybe a lot more. But in addition to that, we've had other viruses such as Ebola virus in Zaire, which was 90% fatal. We've had Lassa fever virus, about 25% fatal. Got hepatitis A, hepatitis B, hepatitis C. All these are epidemic viruses causing epidemics right now. So there's no question whatsoever that viruses are very dangerous and are threatening us at the moment.
You talk of new ones, and you think there are new ones that are going to emerge?
Well, the important thing to grasp about what we call new or emerging viruses is they're actually not new in nature. They already exist out there. Millions and millions of viruses exist in nature. Every creature on Earth has viruses that co-evolve with them, is the expression.
Viruses have been evolving alongside us for millions and millions of years, and it's been a constant battle. In fact, it's war.
War? But what sort of super effective strategy are these viruses using against us?
Okay, so what we have here is a group of cells of the body, and these are some viruses up here. And the first thing that a virus does when it gets into the body is it's got to attach to one of these cells here, because that's the only way it can divide. And it does that by attaching to particular molecules on the surface of the cell there. Now, it can only get into particular cells in the body because only some of the cells have those particular molecules. Once a virus has got into a cell, one of the first things that it must do is it's got to unwrap itself. It takes off its coat like that, and then it releases its genetic information, that's DNA or RNA, out into the cell. And then following on from that, these molecules have to start dividing. Now, we're just showing one virus on this, though in fact a cell may produce hundreds or thousands of viruses every day if it's infected. The virus assembles new proteins around itself and starts to bud off from one cell, and it may go on to infect the neighbouring cells, which are usually going to be of the same type. Once a virus has come out of the cell, it will spread along, and if it weren't for the immune system, the spread of the infection would be extremely rapid.
It needs the human cell, though.
It cannot do without it. It's the only way it can divide.
Your body is being damaged by this viral attack. That's why you might feel pain in your joints, for example. And meanwhile, your own white blood cells are sending signals to the brain, telling it to put your body temperature up, make you feel sleepy, and suppress your appetite. All of those make you feel terrible at the time, of course, but they help the body fight back.
Nearly all of the really dangerous viruses that have emerged in the last 40 years or so have come from the rainforest areas. And we're increasingly encroaching upon those wilderness areas. People are going into them, they're chopping down trees, they're disturbing the local animal life, if you want, and the viruses are coming out of there. It's rather like an anthill that stood in the jungle for millennia, and then suddenly comes in and knocks it over. The ants come out. We now live in something we call the global village. For example, every country in the world has got big cities, teeming populations. Those countries are all interlinked with global air travel. So a virus now will get around the world at the speed of a passenger jet. That's never existed before. So all the goalposts have been moved. We're into a much more dangerous scenario if one of these viruses emerge.
It's particularly hard to get to grips with viruses because they're just so tiny. In fact, they're the smallest disease-causing thing there is.
Entire populations of animals have been made extinct by viruses. So we're an animal, we're all very similar, we're all the members of the same species. We're not even a number of different species. So there's no question that a virus, a killer virus, could potentially wipe out the human species. I don't think it's a very likely scenario, and not in the immediate future, so don't get terribly alarmed. I think a much more plausible scenario is a virus will emerge that will perhaps, rather like the AIDS virus, but it'll spread in a by aerosol spread, such as an influenza or a cold.
At the end of the First World War, a flu epidemic swept across the globe that killed 40 million people. Unbelievably, more people than had been killed by the fighting. Medical science was obviously a lot less sophisticated than it is now. But over 80 years later, the virus still hits a proportion of the population every year. The Public Health Laboratory Service is involved in a huge military-style operation, attempting to keep tabs on the advance of the virus so that appropriate vaccine defences can be prepared in time for an onslaught. But what I wondered was, considering all the information that's been gathered on the flu over the decades, why are we still so bad at handling it?
It's a good question. I wish I could give you an answer. The influenza virus is unusual in that it is able to mutate rather more frequently than we're able to keep up with. The consequence of those mutations is that the genetic material of the virus changes rather rapidly, and we are nearly always one step behind where the virus is. So as soon as we've learnt about the properties of the flu virus, it has moved on.
So in that case, how do you prepare every year for an outbreak?
We do what could be described as a best guess based on rather intensive surveillance and monitoring throughout the world. Basically, the flu tracking system was set up towards the end of the 1940s and is composed of a number of laboratories worldwide which are acting as monitoring stations to look at new viruses popping up all over the world. The information from those different laboratories is put together centrally once a year. That information is looked at, and from that a decision about next year's vaccine is made. And most of the time it works very well, but occasionally we'll be caught on the hop and new flu viruses will emerge in between the time of making a decision and the time that vaccine is actually needed.
The advanced state of vaccination and global surveillance programs may be impressive, but I'm almost more impressed by the resistance put up by our own bodies. Because for every virus you become aware of, your body probably sees off many that you never know a thing about.
There's a combination of things. The first thing, of course, is the skin, which is a very good barrier against most things. And then after that, we have a series of defenses within our body. For example, we've got a kind of early warning system that works between cells to alert one cell of the body that another's infected. And most important, our lymphocytes, the cells of the immune system, are capable of destroying any cell that becomes infected with a virus. And then right at the end of the process, we produce antibodies which are capable of preventing us getting reinfected with the same virus again. So we have quite a lot of layers of defense to prevent us getting serious virus infections.
Our bodies are not exactly defenceless then. But that World War I epidemic still hit the world pretty hard. So I'm not fully reassured that it couldn't happen again.
We need a strategy on this.
We seem to be relatively well prepared for dealing with flu. How does it compare to other viruses?
Well, in the sense that we are prepared, we're well prepared for the ordinary epidemics of flu that happen year by year with vaccinations and so on. Pandemic flu is a different scenario, and I think that would be a much more difficult thing to control. In fact, it behaves very like an emerging virus. But of course, for new viruses such as Lassa, Ebola, AIDS and so on, when these viruses first came out, we'd never encountered them before. It took us years even to find the virus. You can't find a virus very easily. It's very difficult things to track. They're so small that the normal test you do for a virus assume you know what the virus is. If you don't know what the virus is, certainly if you've never met it before, it's almost impossible to diagnose. You don't know what you're dealing with for at least 2 years, unless you're really primed for it. And then controlling it with, you don't know whether any antiviral drugs are going to have any effect whatsoever, and of course there's no vaccination. Totally different ballgame.
The idea of an undetected killer virus being amongst us, which travels through the air, is horrific. Well, let me give the last word to David Mail, who seems less perturbed about this than I expected.
But the thing is that all the people here are different. Not just that they appear different, but the way their immune systems work is different from each other. And that means that only some of the people are able to get infected in the first place, and only a proportion of them will then go on to get a serious infection.
Do you think this is a reason why maybe a virus couldn't wipe everyone out?
Yeah, I think you could have viruses that are serious and a lot of people would be infected, but the point is that you couldn't get the perfect virus that would kill everyone, because what might be a really serious virus for you is not so serious for me, and vice versa.
What about Frank Ryan's idea, though, that there might be something that we don't know about, a new virus that we've not come across? We couldn't fight it.
Well, we've been evolving new viruses over millions and millions of years, and the very fact that we're here at all means that we have been able to fight off viruses in the past. So there are new viruses, there will be new viruses, but I think the human race will survive them anyway.
So I've heard a lot of evidence, some of it reassuring, some of it rather alarming. Here's what I think my take-home messages are. New viruses have been emerging for millions of years and will continue to do so. They are super efficient at invading the body, but then our bodies have developed many ways of fighting back. Nowadays, viruses can spread extremely rapidly, but we have medical understanding on our side in the fight against them. And finally, differences between individuals mean that it's unlikely there could ever be a 100% killer virus. But then again, even 40% extinction would radically affect our civilization. So, are you reassured or freaked out? Well, that probably depends on your outlook on the world.